Hello everyone. Now let us see about a representation of a Turing machine. A Turing machine can be represented in three different forms. One is mathematical form, that is we define the transitions, and next one is transition tabular form or tabular form. We represent transitions in the form of a table, and finally a graphical representation. Meaning it means that we represent all the transitions in the form of states, arcs, labels, etc. Let us see three different forms by a small example. Consider an example. In this we are going to design a Turing machine which is going to accept set of all strings that are ending with character A. And the input symbols are given as sigma is equal to A comma B. First mathematical form is defined as by the following transitions. Let us assume that the initial state is Q0. We know that transition function is defined as it is a mapping from Q cross tape symbols to Q cross tape symbol and direction. A sample transition may the given language contains set of strings of the form A, minimum string is A or any number of A's, or starting with B and ending with any number of A's, or combination of A's and B's, or anything. We have to make sure that every string should end with character A. That means that we have to accept whatever we are in the state Q0, initial state is Q0. It comes across with the input symbol A and it moves to again Q0, and we are not going to bother about changing the tape contents. We are keeping it same and moving one cell to the right direction. Next, Q0 may come across with input symbol B. Again, we don't want to change the tape symbols. Again, it is remained as itself, and we move to the one cell to the right direction. After repeating this act as a loop because we are not changing the state. So at a particular time, Q0 may come across with blank symbol. Then we change to the state Q1. Then we change to the state Q1, and we keep that blank symbol as it is, and we move one cell to the left direction. Next, now current state is Q1. Then we come across with input symbol A. Then we finally accept the given string QF A direction. It doesn't matter whether you move to the left direction or the right direction. Now let us see second form, transition tabular form. State symbols include input symbols A, B, and we are not introducing any new symbols, so input symbols are A comma B, and finally blank symbol, that is B. And the states that we come across are Q0 is the initial state, Q1, and finally accepting state is QF. Q0 when comes across with A, the transition defined is we are staying in the same state and the tape symbol is not modified, so it is A again, and we move to the one cell right direction. Again, Q0 when come across with input symbol B, it is defined as Q0 B R. When Q0 come across with blank symbol, we are moving to the state Q1. We are keeping that blank symbol as it is, and we are moving one cell to the left direction. When Q1 come across with the input symbol A, we are moving to the state QF, keeping that symbol as it is, tape symbol as it is, and we are moving to the right direction, one cell. It doesn't matter whether you move to the left direction or right direction when you reach to the final state. These are all transitions that are not defined. This is second form of representation of a Turing machine, and third form is graphical representation. In this, we represent states inside a circles. We are having the states Q0, starting state, Q1, and finally QF, final state, accepting state. Q0 when comes across with the input symbol A, it is staying in the same state Q0, and we are not modifying the content of the tape, and we move one cell to the right direction. Again, same with the input symbol B. Q0 when come across with blank symbol, we move to the state Q1, blank symbol. We are not modifying that blank symbol, and we move one cell to the left direction. Q1 when come across with input symbol A, keeping that symbol as it is, A, and we are moving to the state QF, and finally moving one cell to the right direction. In this way we can represent a Turing machine. Anything is a valid representation. We can either use mathematical form or a transition table or a transition diagram, graphical representation. This is also known as transition diagram. Consider an example, sample string A, B, A, B, A, and finally blank symbols. Initial state is Q0, and the input string is AB, AA, BA, B. Blank symbols. Q0 when come across with input symbol A, it stays in the same state Q0, and we are not going to modify the tape symbol A. Q0, B, AA, BA, B. Next, Q0 come across with input symbol B. Again, we are staying in the same state, or you can also see here, or you can also see in the transition table. Q0 when come across with input symbol B, we are staying in the same state, and B is left as it is, so still it is remained as B itself, and we move to the state Q0 again, and next input symbol to be traced is AA, BA, B. Next, Q0 when come across with A, again Q0 when come across with input symbol A, again it is remained as A itself, and we are staying in the same state. A, B, A. Q0 when come across with B, same state, B itself, Q0, A, B. Again, A, B, A, B. Q0 when come across with input symbol A, we are staying in the same state, and no modifications in the tape symbol, Q0, B. Now observe that Q0 come across with input symbol B. When Q0 come across with input symbol B, we are moving to the state Q1 and making that blank symbol as it is, and moving one cell to the left direction. That means AB, AB, A. Q0 come across with B, we are changing to state B, Q1, and we move one cell to the left direction, and now read write head positions here. Next Q1 come across with input symbol A. When Q1 come across with input symbol A, means that we are making sure that the last character is A. So we need to accept such strings which are ending with character A, last character as A. So we are moving to the state AB, 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 A, blank symbol, and finally we are moving to the final state QF. In this way, we can accept strings in a Turing machine.